We're going to solve a first order ordinary differential equation by using an integrating factor. You'll know to use an integrating factor when the equation looks like this. Equation number one, it's just y prime with the coefficient of 1, and then you have a y term with an x coefficient, and all other constants and x terms are moved to the other side of the equal sign. Our example will be y prime minus 2xy equals x. Notice that the coefficient of y prime is 1. That's the most important thing to do before you start solving. You're going to want to make sure that the coefficient for y prime is just 1. After that, you're going to want to identify what the coefficient for y is and make sure that everything on the other side of the equal sign has only x terms or constant terms. Now we're able to see that p of x, according to the first equation, is negative 2x. It's important that you take the negative sign with you because in the first equation that was just a plus sign, so the negative has to go with you for the p of x, and that g of x is just equal to x in this case. The first step is going to be just to actually create your integrating factor mu. Mu is always created by just raising e to the power of whatever the antiderivative is of p of x. In this case, p of x was negative 2x, and so mu will be e raised to the power of the antiderivative of negative 2x dx. And after you simplify, it would just be that mu equals e to the negative x squared. We don't need the plus c. It's just the standard way of solving these problems. You can forget about the plus c in this case and just add the plus c at the very end because there will be a second integral that we need to solve. After you've created your integrating factor, you can move on to step 2. The next step would be to multiply both sides of the equation by your integrating factor. In this case, that's e to the negative x squared. You want to multiply that on the left side of the equal sign and again on the right side of the equal sign. After distributing, it would look like this. And notice how on the left side of the equal sign, you might not see it at first, but it always works out this way, where after you distribute the integrating factor, it turns out that this becomes just a version of the product rule by implicit differentiation. That is, everything on the left side can be simplified just as you see it there on the last line. The implicit derivative of e to the negative x squared times y. And if you don't see that simplification right away or ever really, it doesn't matter too much. Technically, once you find your integrating factor, you can just skip to this very last step that you see here in black. That's because it's the strategy behind using this technique where you find the integrating factor and you can just skip down to the last line. So you don't really need step 2 essentially because it always works out where you have d dx of whatever your integrating factor mu is times y equal to your integrating factor times your function g of x. Next, what you're going to want to do is you're going to start simplifying so that you can isolate the y term. You can start by multiplying both sides by dx. And then you can take the antiderivative of each side. Notice on the left side, you have the antiderivative of the derivative of e to the negative x squared times y. So those just cancel. And on the right side of the equal sign, I just multiply by negative 1/2 on the outside of the antiderivative, so that on the inside of the antiderivative I can multiply by negative 2. This is just getting the integral set up so that I can use u substitution. Now I'm just going to move everything up. And after you solve the integral on the right side, you should just end up with e to the negative x squared times y equals negative 1/2 e to the negative x squared plus c. In this case, we do write the arbitrary constant c, but again, we only really need it on the right side. That's because if you write it on both sides, you just subtract one from the other to create a new arbitrary constant. And finally, remember, we're just wanting to solve for y, so in this case, we'll divide everything by e to the negative x squared, and what you'll end up with is y equals negative 1/2 plus c e to the x squared.